All right, we'll start out in 8.5. And y'all, this section deals with rational functions. And y'all, when they talk about rational functions, they're talking about fractional. So the first two problems are finding the domain, and they want the domain in interval notation. So this is just a repeat of what we done earlier in the year with the domains. So first two want us to determine the domain of the function. And y'all, like I said, on these two, they want us to type the answer in interval notation. Y'all, so for my first one, I got f of x equals x squared over 10 minus x. So if you remember, when you're looking for the domain of a fractional expression like this, we're only concerned with the denominator. And remember, the denominator cannot equal 0. So actually, to solve this, I set the bottom equal to 0. And then I solve it for that variable. And then whatever answer I get, I'm going to kick it out of my domain, okay? So on this one, I'm going to start out by subtracting 10. So that cancels. I get my negative x equals negative 10. And then divide both sides by negative 1. So it's going to make that x positive. And then that's going to make that 10 positive. So two negatives make a positive. So if we put a 10 in there, 10 minus 10 equals 0. So that's why we got to exclude 10 from the domain. So to write this in interval notation, we start at negative infinity. And since we're kicking 10 out of the domain, we got a union around that 10. So that kicks out to 10. And then from 10, we go to positive infinity. So this problem is just like we had on test 1 when we were doing the domains, okay? Now, number 2 will be a little bit different because they're going to throw a quadratic equation on the bottom instead of just a 10 minus x type equation, okay? So y'all, this one, I got f of x equals negative 3 over x squared plus 2x minus 24. All right, so this one, I'm going to set this equal to 0. And then I'm going to solve this by factoring. Now, I will show you another way to get these two answers by graphing this. But they will factor. So x squared will be an x and an x. That last number is negative, so you're going to have unlike signs. And then I'm looking for factors of 24 that'll subtract and give me a 2. And y'all, that'd be 6 and 4. So 6 is bigger, it's going to be positive like the middle. and then the 4 will be negative. And then you're going to set both of these equal to 0. Hey, also the first one, you're going to subtract 6 from both sides. Our second one, we will add 4 to both sides. So the two numbers I'm going to kick out are going to be negative 6 and 4. So before I actually do the interval notation, let me show you that there was another way to get them two answers. And that's by actually graphing these. So if you don't like factoring a lot, let me show you this. You can put the x squared plus 2x minus 24. Now, I'm looking for x-intercepts when I graph it. So I'm going to hit graph. And y'all, there it is. It's crossing over here, -1, -2, -3, -4, -5. It's crossing at -6. And then if you go to the right, 1, 2, 3, 4, it's crossing at that +4. And if you want to look at the table, you can see at 4, I got a 0. And then let me go up here to -6. I got a 0. So that's telling me that -6 and 4 are the solutions, okay? So y'all, either way, you got to do that to solve that. So now you got to put this in interval notation. So you start at -infinity. And the first number I got to kick out is -6. So I union around that -6. The next number I got to kick out is the 4. So I'm going to union around that 4. And y'all, those are the only two numbers I kick out. So from here, I can head towards infinity. Okay, so that's the trick on those, was to set the denominator equal to 0 and find what numbers you had to kick out of your domain. All right, so next we're going to look at a few definitions here. So the first definition will be what we call a vertical asymptote. All right, y'all, so a vertical asymptote is an imaginary dotted line that occurs where a graph is undefined. So what's happening at these kind of numbers we found up here? So you'll see that these vertical asymptotes correspond to these domain questions, okay? So it's an imaginary dotted line that occurs where a graph is undefined. They come into form of x equals some number. And remember, since it's an imaginary vertical line, vertical lines are the ones we graphed that had the x equals the number, okay? All righty. Now, there's things you got to look at on these. If the numerator has a factor, so if the numerator that matches the same factor in the denominator, then the vertical asymptote is canceled. And creates a hole in the graph. All right, so let me do one sort of, well, actually this one I graphed a while ago. My function was undefined at -6 and 4. So what happens at -6 and 4 on the graph? So say over here was +4, and over here was -6. What's going to happen on this graph? And let me go graph this for you so you can see. All right, so I'm going to graph the whole function. So I'm going to make it look like a fraction by hitting the alpha y equals and enter. So on top, I had a -3. On bottom, I had an x squared plus 2x minus 24. Now, the thing you got to remember about these vertical asymptotes is there's an imaginary dotted line there. The graph cannot cross over that dotted line, okay? So watch what happens at those two values. See over here at -4, one side is going straight down and the other side is coming from the top. It does that forever. But the graph cannot cross over that sort of imaginary line sitting there. And that's the same thing that happens over here at the +4. Okay? So if you were to trace it, see my cursor? It's just going to keep going up, and then it comes down on the other graph at the bottom. Alrighty, so just remember the graph cannot cross over the vertical asymptote. All right, y'all. And then the last thing to find vertical asymptotes, we set the denominator equal to 0. And solve for the variable. Which is just what we did up here when we find a domain. So if you can find the domain, you can find a vertical asymptote, okay? Because remember, these are the spots where the function was undefined at, okay? All right, so the next few examples, we're going to be finding those vertical asymptotes. And then I'll show you an example of one that made a hole in the graph, okay? So y'all, for these examples, we're going to find the vertical asymptotes. Of the graph of the function. All right, so these started around number 3. So y'all, the first one they gave me is f of x equals 1 over x minus 2 squared. So I'm going to set this equal to 0. And y'all remember, x minus 2 squared is a x minus 2 times x minus 2. Now, since I'm solving this, I don't want to FOIL it. I just want to take both of these and set them equal to 0. But y'all, I've got the same factor happening. So to solve these, I'm just going to add 2 to both sides. And both of them give me the same answer. So since I got a repeat, I don't have to write this answer but once. So my vertical asymptote, and they'll say the equation for the vertical asymptote is x equals, and then we put in our number, which was 2. So this one, they gave me the x equals. You gotta watch and make sure whether they're giving you that x equals or not. If they don't give you the x equals, then you gotta put it, remember, because these gotta look like an equation. So that means on this function, if you were to draw a vertical imaginary line on the x-axis at 2, this graph could not cross it. You know, that makes sense. You can't put a point where something's undefined, right? Oh, y'all try this one. We got an f of x equals x minus 5 over x squared plus 2x. And really all they're doing is just messing with you on these bottoms and hitting you with different ways of solving it. All right, so I'm going to set that equal to 0. So y'all, when you got an x squared and a number with an x, and you don't have that third term up here, if you got x's in both of these terms, your first move is to factor out an x. So you would factor out an x, and then an x squared divided by x leaves me an x plus 2x divided by x leaves you a 2. So when you factor out a greatest common factor, you're sort of undoing the distributive property, okay? But that's the easiest way to factor this one. And y'all, at that point, I can set both these equal to 0. All right, so one answer is 0. Ain't nothing you can do to that one. The only one we can work on is this second one. So on that, we'll subtract 2 from both sides. And I get x equals a negative 2. And y'all, this one is actually multiple choice. So we would pick the one that had the x equals 0, x equals negative 2. All righty. Same thing. F of x equals x minus 3 over 1 minus x. And I want you to notice the ones that got a single answer, you only have one place where it makes that imaginary vertical line. If you got 2 answers, there's 2 places where it's doing that, okay? So this one only got one x, so it would only have one place where it would be undefined. So y'all to find that, we're going to set 1 minus x equal to 0. All righty, so I'm going to do it like I did with the 10 while ago. I'm going to subtract 1. So that cancels. I got negative x equals negative 1. And then divide both sides by that negative 1. So that's going to make my x positive. And negative 1 divided by negative 1 makes that a positive 1. So the only place this one's undefined is at 1 on my x-axis. All right, y'all, let's see what they got. Number 6 here. So I got f of x equals 3 over x plus 5, x minus 1. All right, so we're sort of happy that one's already factored. So since this is factored, all I got to do is set this equal to 0. And then set both my factors equal to 0. All right, y'all, so here we go. The first one, we'll subtract 5. The second one, we will add 1 to both sides. And I get x equals a positive 1. So I know that this one on the left side at negative 5 would have a vertical asymptote and that positive 1. So y'all over here is negative 5. And then here would be positive 1.
I just made it back from the doctor's appointment.
Okay.
Okay.
I got you in, Tricia. Now, we don't know what the graph's doing on the insides, but we do know it's not crossing over these vertical lines, okay? So let's actually look at it on the calculator. Oh, y'all, so that one was, let me clear that out. I'll make this look like a fraction. Alpha y equals an inner. So this one had a 3 on top. And then on bottom, I had a parentheses x plus 5. And x minus 1. Hey, also when we hit graph, over here at this negative 5, you can tell it's one side going up, one side going down, and then over here at positive 1, okay? Now these lines actually go up forever towards positive infinity and go down towards negative infinity. It's just the way these calculators graph these sometimes, okay? But yeah, that's what's happening at these little asymptotes. So let me go back to my screen real quick.
What are these actually graphing? Like, what would this be used for?
Oh, just for mainly domain stuff. You probably won't ever graph these things. Um, probably more into engineering and stuff.
Okay.
But it's just another way to, if you were doing these graphs by hand, you'd be able to play with these and figure out the shapes of the graph and stuff. And on my last problem, we sort of do one by hand. And you'll sort of be able to see how to graph them using all this stuff.
At least you're honest and know that we will never use this stuff.
Not unless you're doing like engineering, maybe. But most of y'all are doing like nursing or business or something, so you probably won't mess with that stuff. All right, what is this, number 7? All right, so let's see. So 2 more verticals and then we'll get into what we call horizontal. So this one has x squared plus 4x minus 12 over x squared minus 2x minus 8. And once again, we're only concerned with that denominator. So I'm going to set the bottom equal to 0. Okay, so once again, I'm going to solve this one by factoring, but you could graph this to get the 2 answers, okay? All you got to do is graph this x squared minus 2x minus 8, and then it'll give you the 2 answers I'm about to get. So y'all factoring the x squared will be an x and an x. The last one's negative again, so that means one will be positive, one will be negative. And then I'm looking for factors of 8 that'll subtract and give me a 2. Y'all, 8 is 1 and 8, and 2 and 4. So the pair that'll give me 2 would be 2 and 4. Just remember, the larger number gets the same sign as the middle. So the 4 will be negative and a 2 positive. All right, it's factored, so now set both these equal to 0. All right, y'all, so the first one I'm going to subtract 2. And then the second one, I'm going to add 4. So y'all, if I graph this right here in y equals, my x-intercept would be -2 and a +4, okay? And let's see, this one had multiple choice answers. You'll see about half of these will have multiple choice answers, okay? All right, y'all, g of x equals x to the third over 5x to the third minus x squared minus 22x. All right, so this is probably the trickiest one. And it's because you'll see this is going to make one of them a whole. And I'll show you once I start factoring this. But the first thing I'm going to do is set the bottom equal to 0. Now, y'all, the first thing on this one, since you got an x here, an x here, and an x here, our first step would be to factor out an x. So that'll leave a 5x squared minus x minus 22 all equal to 0. Alrighty, I want y'all to notice something. You notice I got this x out here? This x to the third is like an x times an x times an x. So remember before I said if a factor from the denominator matches a factor from the from the numerator, they cancel each other out. So one of these x's up here will cancel out this x. So this is just going to be a hole in the graph at this x value, so we don't have to worry about it. What we got to worry about is what 2 values we get out of this. So y'all, I'm gonna set that 5x squared minus x minus 22 equal to 0. So y'all, your single x on this one will cancel with a single x on top. So you're not getting 3 asymptotes. We're just going to get 2 out of this, okay? Now, factoring's a little trickier when you got a 5 in the front. So I'm going to show you how I can get my 2 answers by doing some graphing. Now, let's go to graph this. I'm going to show you a trick I had to show y'all last Friday. So y'all let me clear everything out. Now I'm only worried about the 5x squared I had. So 5x squared minus x minus 22. So let's graph it and see if we can find anywhere where it's crossing the x-axis. And y'all, I got 2 points. So that looks like -2. But y'all, the one on the right, I'm having trouble. I don't know if that's at 2 or not. So let me go to my table. Second graph. So there's -2. I got me a 0. But y'all, +2 and 3. Notice I can't tell what that other 0 is because it must be a fraction. So when y'all was doing that last problem the other day and y'all had a number in front of the x squared, y'all remember I went to the table set by hitting second window, and I went down to the triangle. So since I had a 5 in front, I'm going to make this go by 1 divided by 5. I'm going to make it go by fifths instead of by ones on this. So remember, you're going to match whatever number's in front of the x squared when you do the fraction, okay? But y'all watch this. When I go to second graph to my table, all right, there's my -2. So the other one was down here between 2 and 3. So let me arrow until I find 2 and 3. All right, there's 2. Oh, look at that. At 2.2, I got a 0. So 2.2, and then the other one was up here at -2, remember? So let me get back up there. And at -2. Now, the only thing is that 2.2, I've got to turn that into a fraction. So I'm going to hit math and enter twice. So that gives me 11 fifths. So I know my 2 answers are 11 fifths and -2. Now, y'all, let me do one thing here. I'm going to go back to y equals, because that table, remember, that table is set by fifths. So if I want to go back to my normal table, I hit second window for my table set. And I'm going to go down here to 0.2 and change that back to a 1. Now, when I go second graph for my table, it's back to going by ones on that, okay? So y'all, when you got numbers in front of the x squared, it's a little trickier than factoring like I did here. So graph it and then set the table to 1/5 or whatever your first number is. If you got a 3 here, you're going to go by thirds, okay? But it separates the table now by fifths is what I needed, okay? So y'all, that's the trickiest one. And it's just because you got that number in front. All right, y'all, next definition. Horizontal asymptote. So let me go graph one and I'll shorten show you the difference between a horizontal and a vertical asymptote. And I'm just going to do a basic one. How about 1 divided by x? So a basic graph, 1 divided by x, but when I hit graph, you can see the vertical asymptote is right on the y-axis there. One side's coming down and the other side's going up. But y'all, horizontal asymptote, if you look at this graph, and I'm going to trace it real quick. Watch this graph as I trace out to the right. Look at them y values. The y values are getting smaller and smaller and smaller. The further I go out, the closer this is going to try to get to 0. But notice it's getting closer to 0 the further I go out. But y'all, guess what? It never reaches 0. It just keeps trying to get to the 0 as you head towards infinity. So this will go to 0.04, 0.03. It's getting closer and closer as you go. But y'all look at that. It'll never get to 0, okay? So that is a horizontal asymptote. So let's write that. So technically a horizontal asymptote is an imaginary horizontal line that the graph tries to approach. That the graph tries to approach as the x values head towards negative infinity and positive infinity. Now they come in the form of y equals some number. Okay? So like the one I just showed you, it was trying to get to the x-axis. This would be y equals 0 because it's trying to get to that 0, okay? But y'all, horizontal asymptotes got 3 cases. So the 3 cases for these horizontal asymptotes. Now, horizontal asymptotes depend on the degree of the numerator versus the degree of the denominator. And remember, the degree is the highest exponent, okay? So the first case, if the degree of the top is greater than the degree of the bottom, so if my exponent on top is bigger than the exponent on the bottom, then there is no horizontal asymptote. And y'all, that's because the top's growing bigger than the bottom, so it's always going to grow bigger on the top. So they're going to head off towards infinity, and there's not going to be a horizontal asymptote. So the second case is if the degree of the top is smaller. So if it's smaller than the degree of the bottom, well, if the bottom has a larger degree than the top, then your horizontal asymptote will be y equals 0. So it'll be like the one I drew a while ago with the 1 over x. It's going to try to get to 0 as it heads out towards those infinities, okay? And y'all, the last case. So we had the top greater, no asymptote, bottom greater, y equals 0. What if they're equal? If degree of the top equals the degree of the bottom, then, all right, so they're equal. I got an x squared on top, x squared on the bottom. Those are my largest exponents. If they are equal, then the asymptote will be y equals a over b, where a and b are the lead coefficients. So the lead coefficients are the numbers in front of the variables with the highest exponents, okay? So y'all, there's 3 cases of these, and they're going to give us an example of all 3 of these, okay? So the trick on these is to figure out where the degree is larger or if it's equal, okay? So for these, we're going to determine the horizontal asymptotes. Oh, what am I on? My number 9, I think. All right, y'all, so here we go. I got f of x equals 5x to the third plus 4 over 3x to the third minus 2. So the top degree is 3, because that's my highest exponent. The bottom degree is 3. So they are equal. So since they're equal, my horizontal asymptote will be y equals a over b, which means y will equal the lead coefficients. And y'all, the lead coefficients are the 5/3. So a will be 5, b will be 3. So remember, if they're equal, it's the fraction where a and b are these lead coefficients. Okay? Now, y'all, they got the y equals part, so you just got to put in the 5/3. All right, y'all, let's try this one. F of x equals x squared minus 5 over 3x to the fourth plus 5. So let's see, the top degree is 2. The bottom degree is 4. So it looks like the bottom is greater than the top.
Y equals 0.
So that's going to be y equals 0 automatically. Good job. And then let's see, so they put the y equals part, all y'all got to put in is the 0. So these ain't bad. You just got to go off them 3 cases and look and say, hey, am I equal? Is my bottom greater or is my top greater? Okay. Ooh, all right, y'all, look at this one. X to the third minus 2x squared plus a x minus 4 all over x squared minus 18. All right, so let's see. The top degree is 3.
There would be no horizontal asymptote.
Right, because my bottom degree is what, 2? So my top is greater than my bottom. So good job. So you would click, it has answer B, no horizontal asymptote. So if you used to graph something like this, you would see that instead of trying to get down to a line, those things are heading on off towards infinity, okay? All right, y'all, so this last problem was a little bit of a graphing one. So let me show you how you would graph one of these by hand. So y'all on this number 12, they want us to list the domain, X and Y intercepts, all the asymptotes, and graph. Now they'll have 4 pictures of the graph, so if you don't want to graph them by hand, you can graph them on your calculator, okay? All right, y'all, they're giving us f of x equals x minus 2 over x plus 4. All righty, so my domain. And on the domain, they want interval notation. But remember, to find my domain, I'm going to set that bottom equal to 0. And then solve that by subtracting 4. Now, I've done found 2 things on this. I can now write my domain and kick out this number. I also know this is my vertical asymptote, because we find vertical asymptotes the same way as we find our domain stuff, okay? So for the domain, I would go from negative infinity to that negative 4, union around that negative 4, and go to positive infinity, okay? Now let's see what they're asking. So y'all, here's how you find the X and Y intercepts. The Y-intercept. We're going to find the Y-intercept by setting, well, by basically finding f of 0. Remember, the Y-intercept happens where the X value is 0. So we just put zeros in for these X's and see what we get. So 0 minus 2 over 0 plus 4. Y'all, that's going to give me a negative 2 over 4, which is a negative 1/2. Now remember, y-intercepts come in this form, so you'll have a 0 for the x and a negative 1/2 for your y value, okay? To get the x-intercept, you set the numerator equal to 0. We are the numerator is x minus 2. I'm going to set that equal to 0 and solve that by adding 2. So my x-intercept is 2, but remember, as a point, that is going to be 2 comma 0. So notice the y-intercept has an x value 0. The x-intercept has a y value of 0. All right, I know my vertical asymptote. So we're just going to initial vertical asymptote. Well, it's the same as the domain. So that's going to be x equals -4. So let's look at our horizontal asymptote. Well, y'all look at this. The degree on top equals the degree on bottom. So the degree top equals degree bottom. So this is the y equals a over b. But y'all, I don't see no numbers in front of those x's.
One.
It's going to be 1. So you got to treat that like a 1x and a 1x. So this will be 1 over 1, which is 1. So for my horizontal asymptote, it'll be y equals 1. And y'all, I think they give you the x equals here and the y equals there. Now, it'll ask about an oblique asymptote. We don't cover these, so on this question, put no oblique. Okay, but oblique one would be one that sort of goes at an angle. But y'all won't have that, so on this oblique, you're going to put no oblique asymptote, okay? So y'all, let's sort of graph it and see what we know. So y'all, I'm looking at all my numbers. They're fairly small, so I'm going to go out about 5. And I really think they just wanted y'all to know how to do this stuff because you can actually graph these fractional equations. Now, the first thing I know, I got a vertical asymptote over here at -4. So there's my imaginary vertical line. My graph cannot cross over that. So what else do I know? I know my y-intercept was 0, -1/2. Well, here's 0, -1, so -1/2 will be about in the middle there. Okay, so there's -1/2. My x-intercept was at 2, 0. So here's 1, 2. Now remember, that's the only place this graph can cross over that x-axis. But y'all, I got enough now. Because I know this asymptote, if it can't cross this x-axis no more than that, that means this side has to come down and go down toward -infinity. Because remember, it cannot cross back over. And that means this side of the asymptote, this side is also, whoops, I went too high. Because remember, my horizontal was out here at 1. So this graph is really just trying to come up and get to that 1. And y'all ought to do the same thing over here. This side will come in from the top, come down, and it's going to try to get to that 1 on that, as it goes towards those infinities, okay? So let me graph this real quick and we'll verify. So y'all, y equals I always make these look like a fraction by hitting alpha y equals and enter. So I had what, x minus 2 over x plus 4. All right, y'all, so this graph should look really close to what we had, and there you go. Now, the calculator ain't going to draw a dotted line over here at -4. But you see how this, if you was to trace this and go to the right, then y values are going to try to get close to 1 as you go out. Say I'm at 0.3, 0.4. The further I go, it's just going to keep trying to get closer to that 1.
Do we have to graph the asymptotes on lab?
No, you're just going to pick
Okay.
one of these. So you've seen what my picture looked like, right? So
Yes.
let me show you what you'll have to do on this one. No, they're sort of nice. They don't make y'all physically graph them. They just make you pick one of these 4
Okay.
pictures. And I think the one we had would be B here, right? Ours came up and sort of crossed and went out as you went.
Okay.
So yeah, once you graph them, you can find your picture and be done. But technically, that's how you would do them by hand. So you need a lot of information to do these things by hand, okay? So y'all, that's 8.5. So next we got 8.6. Oh, y'all, look, it's almost it's time for our break. So let me stop my share a second. And then we'll pause this. Alrighty, also 8.6 deals with polynomial inequalities. And remember, inequalities are less than, greater than, less than or equals, or greater than and equals. All right. And in this section, we write our answers in interval notation. So I'm going to write the steps to solving. All right, y'all. So our first step, we're going to set our polynomial equal to 0. Okay. Then we will solve the polynomial. So solve for the variable. So we should get 2 answers. So now, since these are inequalities, these deal with greater than or less than. So you can have more than one answer on these, or more than one solution that makes them true. So the way we find what sections are true or false is we make a number line using the solutions. So you're on my number line. I'll have 2 answers. I'll have my first answer and my second answer. So I'm going to make a number line using my 2 answers. Now, we have to test these sections to find whether it's true or false in these sections, okay? Before we can make our interval notation up. So, I usually test 0. Test 0 to determine if it is true or false. Now, 0 could be in the middle section or it could be on one of the end sections. But I always use 0 because 0 is the easiest number to plug into the polynomial and determine whether it's true or false, okay? Now, if true, shade the section 0 is located. If false, we don't shade the section where 0 is located. If false, we shade the other sections. Now, there's two ways these will look. So y'all, if 0's in the middle and it's false, then I would shade the outside sections. If 0's in the middle and it's true, I would shade that section where the 0 was located. Now, your answers will look like this, or they will shade on the ends. If it shades on the left end, it's going to shade on the right end. If it shades in the middle, it's only going to shade in the middle. Okay? Now, here's where you got to watch out for when you're writing these answers is interval notation. Write answers in interval notation. Now, if it's greater than or less than, you're going to use parentheses. If it's greater than or equals or less than or equals, we're going to use brackets. So if it's equals, we're going to the brackets just like we have in the past, okay? Now, two things you got to watch out for. If we only get one solution, now the only way you'd get one solution if it was one of those repeating factors like x minus 2, x minus 2. So if we only get one solution, then that is the only number we exclude. Okay? So my interval would go from negative infinity to 2, union 2 to positive infinity. So one solution is the only number we exclude from the domain. Now there's another thing we got to worry about. If the polynomial does not factor, then we have no solution. Now, in MATLAB, no solution looks like a 0 with a line through it. And they'll actually have one of the buttons down there, like by the infinity. It'll have this. This is what we use for no solution in MATLAB, okay? All right, y'all, so I'm going to follow these steps. I'm going to set my polynomial equal to 0. I'm going to solve it for the variable. I'm going to make my number line and then start testing it, okay? So y'all, let's go have some fun with these. Now, these will say solve the following inequality. All right, y'all, so let's start out with this one. X squared minus 14x plus 33 is greater than 0. Now, I want to show you what's going on with this. So let's go graph this real quick. Because we're looking for the part of this that is greater than 0, okay? Now, I'm going to show you how it looks on the graph, and then I'll actually work this by hand, okay? So I'm going to clear this off. So, y'all, we had an x squared minus 14x plus 33. All righty, let's graph it. And by graphing it, you'll find the actual solutions to the polynomial when we set it equal to 0. You see it crosses over at 1, 2, 3. It's crossing at 3. And then let's see, 4, 5, 6, 7, 8, 9, 10. So it's crossing at 3 and 11. So those are going to be my two answers that I'm going to make my interval out of. But y'all, what I'm wanting y'all to see is which part of this graph is greater than 0? Which part is above the x-axis? Well, that's this left side over here and this right side. Those are the two parts that are greater than 0. This middle part here, that U shape right there, that's below the x-axis, so that's not greater than 0. That part would be less than 0. Okay? But ours was greater than 0, so when we're done, we're going to have this left side and the right side in our interval notation, okay? But y'all just wanted y'all to sort of see visually what's happening with these. So let's go actually solve this. So to actually solve it, I'm going to set it equal to 0. Now I'm going to solve it by factoring. So I got an x and an x. Now remember though, when I graphed it, I seen that my answers were 3 and 11, okay? So y'all here, the last number's positive, so both of these factors will be negative like the middle. I need factors of 33, that'll equal 14. So 1 and 33, what else is there? 3 and 11. And y'all, that's the only way to get a 33. And the two that add to 14 are 3 and 11. So mine are both negative in factor form, but y'all watch this. I'm going to set both them equal to 0. And solve them both. So the first one will add 3. So there's our positive 3. The second one, I'll add 11. And there's my positive 11. When we looked at the graph, we knew those were the two answers, 3 and 11. So now I'm going to make my number line. I'm going to put a 3 here and 11 there. So remember, I'm going to test 0. So to test 0, I put a 0 in for this and see if it equals greater than 0. So that's going to give me 0 squared minus 14 times 0 plus 33. That has to be greater than 0. Well, y'all, 0 squared is 0. 14 times 0 is 0. So 0 minus 0 plus 33 gives me a 33 greater than 0. This is true. So since it's true, I shade the section up here where my 0 was located. Remember, 0's up here because 0 is less than 3, right? But remember, if I shade that left side, so let me draw that again. So here's 3 and 11. So since 0's in this section, we're going to shade it. But y'all remember I said if you shade the left section, you also got to shade the right section. Well, y'all, those are the two parts that were above the x-axis. This middle part, that middle U, was below the x-axis, so that's why it's not shaded, because it's less than 0. All right, so now write the answer in interval notation. When you're highlighting the ends like this, the left side's going to come in from negative infinity and go until you hit that 3. Now, do I want a square bracket or a curvy parentheses? Well, y'all, I got a greater than. It does not have equals under it. So that means I use the curved parentheses. And then it'll start at 11 on the right side and goes towards positive infinity. So notice, since there was nothing shaded here, there's nothing in between 3 and 11. It goes from negative infinity to 3, and then it goes from 11 to positive infinity. So interval notation, this is what MATLAB wants. So if the ends are shaded, you'll have 2 intervals, one starting at negative infinity, one ending at positive, okay? Now, if it just shades in the middle, then you'll just go from the number to the number. All right, y'all, let's try this one. X squared minus 4x minus 18 is greater than or equal to x minus 4. So y'all, on this one, the first thing we got to do is get a 0 over here. Because remember, we got to set them equal to 0. So to get a 0 over here, I'm going to subtract an x from both sides, and I'm going to add a 4 to both sides. So add the opposites to both sides. So this will give me the x squared. Negative 4 and negative 1 give you negative 5x. Negative 18 and 4 give me negative 14. This is now greater than or equal to 0. At this point, you can graph this in y equals. You can get your two answers, and then you can pretty much tell what's above the x-axis or what's below, because greater than 0 will be all the parts that are above the x-axis, okay? So if you're doing the graphing, you can graph it and pretty much get everything you need. All right, so at this point, I'm going to set it equal to 0 and factor it. X squared is x and an x. Last one's negative, so I got unlike signs. And I need factors of 14, that'll subtract and give me 5. So y'all, 14 is 1 and 14, 2 and 7. The ones that'll subtract and give you 5 are 7 and 2. Larger number, same sign as the middle. So the 7's negative and the 2 is positive. All right, y'all, so then I would have to set these equal to 0 and solve. So y'all, the first one, I would subtract 2. And then the second one, I would add my 7. So if you were to graph this, you would see that it crosses at negative 2 and positive 7, okay? All right, so I got my two numbers. I got me a negative 2 and a 7. So my 0 is going to be right in the middle. 0 is in between negative 2 and 7. So I'm about to test 0 and see if it's true. If it's true, I'll shade the middle. If it's false, I'll shade the outsides. Now I'm going to go use this one here. So I'm going to put a 0 in. So I got 0 squared minus 5 times 0 minus 14 has to be greater than or equal to 0. Well, 0 squared is 0. 5 times 0 is 0. 0 minus 14 gives me a negative 14, greater than or equal to 0. This is false. So y'all, since that's false, I do not shade where the 0 was located. So if I don't shade where 0 is located, I gotta shade the outsides. So notice, true here, I shaded the section where 0 was, automatically had to shade the last section. Here, 0's in the middle, I don't shade that section. And if you don't shade the middle, you gotta shade the two ends. So you got two intervals, it's going to look like this one. But y'all, the difference is, this one has the equals under it. So instead of using these parentheses, I'm going to use brackets around my numbers. So from negative infinity to negative 2, bracket, and then union from the 7 to the positive infinity. So what means if you put a negative 2 in, it'll equal 0. So that's why we can include negative 2 with the brackets, okay? Because of the equals part of that.
Will there be a where you would put a bracket and then the negative infinity to -2 instead of a parenthesis?
Say again now?
Will there be a time where you do like your bracket instead of doing and then doing your negative infinity to -2 for this?
Oh, like this?
Yeah.
Infinity never has brackets.
Okay, that's what I was.
Yeah, because infinity, there's no stopping point.
So the bracket is more or less just saying we're stopping here and then we start up again at 7.
Yeah. Well, we're starting here, but this number makes it true. See right here, this 3, let me show you what happens. So since the 3 didn't have an equals up here, equal to 0, this 3 will be false when I put it in here. So let me show you that. 3 squared minus 14 times 3 plus 33 has to be greater than 0, right? Well, y'all, 3 squared is 9. Minus 14 times 3 is 42. Plus 33 has to be greater than 0. We all look at this. 9 minus 42 is negative 33 plus 33. So this gives me a 0 greater than 0. Well, y'all, 0 is not greater than 0. 0 is equal to 0. So since when I put that 3 in there, this didn't give me a true statement.
Okay.
So I couldn't include 3. I had to use the parentheses. Okay. Now watch this one. Let me put a negative 2 into this right here. So I would have negative 2 squared minus 5 times negative 2 minus 14 has to be greater than or equal to 0. All right, negative 2 squared is 4. Negative 5 and negative 2 give you a positive 10 minus 14 greater than or equal to 0. Well, y'all, 4 plus 10 is 14 minus 14. I get 0 greater than or equal to 0. So see, this is true because of the equals on it.
Okay.
So since it was true for negative 2, I put that bracket. So are you seeing the difference? This 3 didn't make it true because it didn't have the equals on it.
Okay.
So your endpoints, that's why I'm using like parentheses or brackets. Brackets means it includes that number, to where parentheses means you can get almost up to the 3, but you can't actually equal to 3. Does that make sense?
Yes. Thank you.
Okay. Oh, y'all, this one's not bad. X squared greater than 16. So I'm just going to solve that by setting x squared equal to 16. When I got an x squared in a number, I don't have to worry about getting everything on one side equal to 0 because I got a fast way that I can solve this. If you got an x squared in a number, you know, the easiest thing is to come in and do your square roots to both sides. But remember, on a number, you got to do a plus or minus square root of 16. So y'all, this cancels, giving me my x. That's going to be what, a plus or minus square root of 16, which is a 4. So the square roots give you both the numbers, or you could have factored it, get everything on one side equal to 0. But y'all, square roots are the quickest when you got this kind of situation. So I got a -4 and a +4. I'm going to test my 0 because it's right in the middle again. And really the trick is finding out where 0 is on your number line. So I'm going to test 0, which is 0 squared greater than 16. Well, y'all, 0 squared, 0 times 0 is 0 greater than 16. True or false?
False.
And that is definitely false. So remember, since that's false, and that 0 is in the middle, I can't shade where the 0 is located, which means I got to shade these outside edges. So anything that I shaded would make that true. -5 squared is 25. 25 is greater than 16. -6 squared is 36. 36 is greater than 16. Same thing over here. 5 squared is 25. 6 squared is 36. All these numbers, when you square them, are going to be larger than 16. 4 don't make it true because 4 squared is 16. But y'all, since I don't have that equals under there, I can't include the 4. So I'm going to use my curvy parentheses. So this one would start at -infinity, go to -4, curved parentheses, and then we would union it from the +4 to the positive infinity. But y'all, any number that you square that is bigger than 4 makes it true. Any of these numbers in between, like 3 squared would be 9. Well, 9 is not greater than 16. So if you were to graph this, you would see that this graph would come up like that. And then this bottom part here, which would be less than 0, was the part we didn't shade, okay? So if you're looking at these graphs, you're looking at what's above the x-axis versus what's below it. When it's greater than, we're worried with what's above it. When it's less than, we're worried about what's below that x-axis. All right, y'all, let's try this one. 225 minus x squared has to be less than or equal to 0. So y'all, I'm going to solve this one basically like I did up here. The only thing I need to do is move this 225 over and then take care of that negative, okay? So my first step, I'm going to subtract that 225. So if you notice, that cancels. I get my -x squared is less than or equal to -225. All right, now I want that to be a positive x squared, so I'm going to divide both sides by -1. So if I'm dividing by -1, what are you doing? And y'all remember this, if you divide by negative, this inequality, you have to reverse it. So less than or equal now becomes greater than or equal. And y'all, that's going to be the case anytime you're dealing with inequalities and you divide by these negative numbers. Do not forget to reverse the inequality. Since dividing by negative. All right, so doing that, I now have a positive x squared greater than or equal to a positive 225. All right, so I'm at this point now, so I'm going to take square roots of both sides. And I'm just actually going to make it equal now, like I did up here. All right, y'all, so this gives me an x equal to a plus or minus, square root of 225, y'all. That's a big number there. That should be, square root of 225 should be a plus or minus 15. So, we got our two numbers, negative 15, positive 15. And y'all, when I test it, I'm actually going to do this one right here. And that's the last one I had where everything was set up like I needed, okay? I'm going to test 0. So 0 is in between the negative 15 and 15. So y'all, true or false? 0 squared greater than or equal to 225. Well, 0 squared is 0. But y'all, 0 is not greater than 225. It is less than 225. So this is false again. So when we go to shading, since 0's in the middle and it's false, I do not shade the middle. I shade the outsides. Well, y'all, that makes sense. If 15 times 15 is 225, anything less is not going to be greater. You need numbers that are bigger, like 16, 17, 18. You need to square these kind of numbers to make that true, okay? Now, y'all, I got an equals on this. So this will start at negative infinity until I hit negative 15. And we need a bracket. And then union bracket from the 15 to a positive infinity. Okay. And y'all, if you want to graph this, I can go from the very beginning picture. And I'll show you this one. I'm going to do the part where it says 225 minus x squared. Now remember, my answer was the ends were above the line. So watch what happens when you graph this. Whoops, let me go back to a regular graph. Now we're not seeing it because of that 15. So if I want to see those parts, I got to adjust my window and maybe go from negative 20 on the x's to a positive 20. I got to get my x's bigger than those 15s, okay? But now watch when I graph it. You can see it's crossing over here at negative 15 and positive 15. And the original was less than 0. So see how this is all less than 0? Now, watch what happens when I put it in as a x squared minus 225. Once I took care of all them negatives, there you go. It's the part above it now after we change the equation, okay? So That's how that stuff works. All right, y'all, let's see number. There's only 6 of these, so we got 2 more. So 14x minus 49 minus x squared has to be less than 0. So let me get them in order first. So I need to pull that negative x squared out to the front. Plus my 14x minus my 49 less than 0. Now, before I factor this or anything, we don't want this x squared being negative. So we need to divide everybody by -1. Remember, when you divide, everybody gets divided. Now, since I'm dividing by negative, this less than will now become a greater than. So I got an x squared minus 14x plus 49 greater than 0. All right, y'all, so I'm going to factor this one instead of actually equal to 0. So an x and an x. The last sign's positive, so both of these will be negative like the middle. All right, y'all, 49, I need factors of 49, so I know 1 and 49. I know 7 and 7. And y'all, that's the only way to go. And the 2 that equal 14 are 7 and 7. So notice, this is the first star I gave y'all. Repeating answers. Well, I'm only going to set one of them equal to 0 and solve it. And I'm going to solve it by adding 7. So if you had your number line, you only got one answer, which is 7. So remember, since I only got one answer, that is the only number I'm going to kick out of my domain. And notice, these can't have equals on them. When it's a single answer like this, you won't have equals on it. It'll either be a less than or greater than. But y'all, this one will go from -infinity to the 7, union from the 7 to positive infinity. So if there's only one answer, that is the only answer we're kicking out. All right, y'all, our last one is an x squared plus 22 less than 8x. All right, so this one is the x squared, the number, and the x. So I can't do square roots to this. So what I need is a 0 where that 8x is. So y'all, to make that a 0, we're going to subtract 8x from both sides. So if you notice, all the trinomials, I got everything on one side equal to my 0, okay? All right, y'all, this is x squared minus 8x plus 22 is now less than 0. All right, so I'm going to factor it and set it all equal to 0. X and an x. Y'all, the last number is positive, so both factors will be negative like the middle. All right, y'all, I got 22, which will be 1 times 22. What else? 2 times 11. So I need a pair of factors that'll add to get me an 8. Well, y'all, none of these factors add to get 8. That adds to get 23. This adds to get 13. So this one has no solution. So let me show you what this graph will look like. All right, so I had what, an x squared minus 8x plus 22. All right, y'all, watch this graph. When I hit graph, look at it. It's all above the x-axis. It does not cross the x-axis at all. So there's no part of this graph that is less than 0 because it does not even cross the x-axis. So this does not factor. And y'all, you can tell because it did not cross the x-axis, okay? So when it did not factor, this meant that this was a no solution. But remember, in MATLAB, no solution is a 0 with a line through it. That's what you got to have in MATLAB when it's a no solution, okay? Oh, you also noticed you had 6 problems in here. Number 5 will be like this one. You're only going to get one answer. And then number 6, probably 80% of the time or more, is a no solution, okay? All righty, so y'all, here's the thing. So what's tomorrow? Tuesday? So for Tuesday of this week, we're going to review test 3. Wednesday, we will do 9-3 and 9-4. Thursday, we will do 9-5. And I may do a little bit of 9-6. Not sure. Friday, we will definitely do 9-6. And then next Monday, we will knock out the last section we learned, 9-7, okay? Tuesday, we'll review test 4. Wednesday of next week, we're going to review the final exam. And my final exam will open that Wednesday. This is like July 31st, I think. Thursday, which is August the 1st, final exam will be due.
Is that the semester test?
Um,
The final exam? Is that what that is?
yeah.
Okay.
So it'll sort of be over everything.
Oh, gotcha.
Now you won't see this one until Wednesday when it opens up, but it'll be Wednesday and Thursday, but it's due by midnight on Thursday, August the 1st. At midnight on August the 1st, MATLAB is going to shut down. So y'all remember that MATLAB shuts down at midnight on August the 1st. Because we got to have grades in by that Friday so that y'all can start registering for the fall and all that fun stuff. Now, y'all, this Friday, I got an appointment at like 9:15. So this Friday, class will start at 10:30. So on Friday, instead of starting at 10, we're going to start at 10:30, okay? But y'all, it's not a real long section, so it won't take us too long. This is where we solve logarithmic equations. So I'll probably start a little bit of 9-6 on Thursday. And then finish the rest of it up that Friday. Monday, 9.7 is not very long. And then, like I said, that's the last section we cover for the year. And then Tuesday, Wednesday, Thursday, we're getting ready for the final, okay? And for the last test. Now, y'all, here's some things I'm noticing on y'all's grades. Some of y'all would have really, really, really good grades, but you're not doing the homework. Remember, y'all, this homework in this class, homework is 20% of y'all's grade. Okay? And if you don't do the homework at all, the highest you can get in here would be an 80. That's what 20% means. Your highest grade would be an 80. So you can't even get a B really without doing the homework. So the homework is 20%. Mostly you're getting your participation points, which was 10%. So y'all are mainly getting those. Remember, the rest of this stuff is quizzes or 10%. That's those reviews. The 4 tests, and then your final. So your final is 20% of your overall grade. And these tests are worth 40% of the grade. So notice, if you don't do the homework, the highest grade you'll get is the 80%. Okay? So you want to definitely do the homework. And you can go back and redo any assignment. But y'all, here's the thing. We've only got a week and a half left of class, okay? So if you're wanting any of these 20%, y'all need to get on that homework now. On the testing, there's 4 tests. So the one we'll review tomorrow, and then the one from next Monday. Of those 4 tests, if you bomb one of them, say your 4 tests, say you made a 90, 85, say an 88, and then you made a 64. So here's what I'll do. You come in on my final and you made, say, a 94. If you made a 94 on the final, I will replace your lowest test with that 94. Okay? Now, y'all, the final exam is probably the easiest test because it's all multiple choice. But if you bombed one of my 4 tests, I will replace it with the grade of the final exam as long as the final exam is higher than your lowest score, okay? I will also drop the 2 lowest homeworks. So your 2 lowest homeworks, I'll drop them out totally, and I'll drop 1 quiz. So one of those module reviews you didn't do very good on, I'll drop it out totally, okay? So these 3 things will drop at the end, and I will replace the low score with your final exam score, okay? So at this point, grades are going to go up. But y'all, don't kill yourself. Try to get as much of this 20% as you can on the homework. Then you don't have to kill yourself on the testing, okay? But y'all, like I said, if you don't do the homework, the highest grade you'll get is an 80. And the only way you'll get an 80 is making 100 on everything else. Well, it's hard to make 100 on all 4 tests and a final, okay? So, y'all control the homework. Do as much of that as you can before next Thursday, okay? So y'all, any questions? The main thing, Friday we starting at 10:30. The rest of this week we'll start at 10 o'clock, 10 o'clock, and so on, okay? All right, y'all, any questions?
No questions.
So y'all have almost made it through college algebra for a 5-week summer class. So if you make it through this class, you need to pat yourself on the back because 5 weeks is fast to do 16 weeks worth of material, okay? And y'all pretty
It
happy.
wasn't as
Most-
bad as I thought it was going to be. I was scared I was going to fail.
I heard that. And you've actually done really good on your homework, so good job.
Yeah, I stay on top of it. I work night shift, so I stay on top of it.
Okay, there you go. So y'all go knock out the rest of your 8-5, 8-6. Tomorrow we're going to review for test 3